Good morning 11th class. Today we'll study about wave mechanical model of atom, or either you can say quantum mechanical model of atom. This model is again very important because whatever previously we have learned about Bohr model of atom or either Rutherford model of atom, but this model, quantum mechanical model of atom, this one is totally a new concept and which tells us about the electron probability. इसने हमें किसकी बात कही थी? इसने हमें बताया इलेक्ट्रॉन प्रोबेबिलिटी की बात करी. नाउ जस्ट सी in case of from where that mechanical model of atom comes, किस वजह से आया ये मॉडल something. Okay, now अब तक हमने क्या पढ़ा था? Basically what we have studied. Now that one is according to Rutherford, either according to Bohr, that this one is nucleus and electrons are revolving around the nucleus. What Rutherford said, कि they are revolving with a very high speed. After that their drawback, Bohr also said same thing. Electrons are revolving around the nucleus in a fixed circular path. उसने एक circular path की बस बात करी थी कि that one are revolving in a fixed circular path. But after the principle of Heisenberg principle, or either it's a dual nature of matter, means that one is de Broglie equation. Either you can say de Broglie. Okay, or either it's a de Broglie equation. So according to that Heisenberg or de Broglie equation, okay, what we have studied, that electron have wave nature. This one is electron have wave nature. Now if electron have wave nature, तो बोहर वाला मॉडल तो क्या हो गया? यहाँ पे जो कंसेप्ट था उसका वाला इट प्रूव्स रॉन्ग. मीन्स रॉन्ग इन अ सेंस कि इलेक्ट्रॉन्स आर रिवॉल्विंग अराउंड द न्यूक्लियस. हैव यू सीन वेव? नॉर्मली अगर हम वेव्स की बात करें, कैसे मूव करती है अप एंड डाउन एंड अप एंड डाउन, दैट वी हैव स्टडीड इन अर्लियर वीडियो. ओके, तो इफ इलेक्ट्रॉन हैव अ वेव नेचर, पार्टिकल नेचर इज देयर, दैट्स व्हाई दे आर रिवॉल्विंग अराउंड द न्यूक्लियस. इतने टाइम से रदरफोर्ड और बोहर हमें क्या पढ़ा रहे थे? ये तो पढ़ा रहे थे कि दैट वन इज इलेक्ट्रॉन हैव पार्टिकल नेचर एंड जस्ट बिकॉज ऑफ दैट इट रिवॉल्व्स अराउंड द न्यूक्लियस. बट नाउ इलेक्ट्रॉन हैव वेव नेचर and you know that one is wave will not move like this, कि wave circular path में move नहीं कर सकती. Okay, now for that one simple, that nature of wave, तो electron have wave nature. तो to explain this nature, सिंपल इसको बताने के लिए क्या है हमारे पास? दैट वन इज वेव मैकेनिकल मॉडल ऑफ एटम. दैट्स व्हाई द नेम गिवन इज वेव मैकेनिकल मॉडल ऑफ एटम. एंड Heisenberg, what he said, that one is they talk about very small microscopic particles. That's why name given is quantum mechanical model of atom. Basically quantum means बहुत छोटा. Okay, जब हम क्वांटम की बात कर रहे हैं तो क्वांटम मीन्स दैट वन इज वेरी स्मॉल माइक्रोस्कोपिक पार्टिकल्स. या एटम और उसके अंदर की कभी बात करेंगे तो दैट्स व्हाई वी आर यूजिंग दिस वर्ड क्वांटम, बिकॉज वट एवर वी विल स्टडी दैट विल स्टडी अबाउट एटम. एटम के बारे में पढ़ रहे हैं उसमें डिटेल, एंड यू नो द साइज ऑफ एटम इज वेरी वेरी स्मॉल, बहुत छोटा होता है. तो दैट्स वाई इट्स अ क्वांटम मैकेनिकल मॉडल. वेव की बात कर रहे हैं, दैट्स वाई वेव मैकेनिकल मॉडल, एंड बिकॉज इट्स अ स्मॉल माइक्रोस्कोपिक पार्टिकल्स, तो दैट वन इज क्वांटम मैकेनिकल मॉडल ऑफ एटम. ओके, नाउ फॉर दिस वन टू गिव दिस नेचर या पूरा एक्सप्लेन करने के लिए बहुत सारे साइंटिस्ट ने काम किया, बट द इम्पॉर्टेंट वन वॉज इरविन श्रोडिंगर. ओके, ही गेव श्रोडिंगर वेव इक्वेशन. क्या कहते हैं इसमें? दैट वन इज श्रोडिंगर भी कहते हैं कई लोग, बट इट्स अ श्रोडिंगर वेव इक्वेशन. Actually he gave Schrdinger wave, मतलब he gave Schrdinger wave equation. Name is given by because name was Erwin Schrödinger. जिस साइंटिस्ट ने इसको क्या दिया था? इक्वेशन दिया. What he said, इसने हमें क्या बताया? इसने हमें सबसे इम्पोर्टेंट चीज़ ये बताई, that one is electron probability. Okay, now what he said, इलेक्ट्रॉन प्रोबेबिलिटी की बात करिए, बिकॉज अब ऐसा तो कुछ नहीं है कि इलेक्ट्रॉन हमें एक सर्कुलर पाथ में मिल रहा है. नाउ ही सेड व्हाट, दैट इलेक्ट्रॉन्स आर, बिकॉज नाउ इलेक्ट्रॉन हैव वेव नेचर ऑल्सो. ओके, इलेक्ट्रॉन के वेव की बात कर रहे हैं, एंड वेव यू नो दैट ट्रैवल इन ऑल डायरेक्शन, मीन्स 3D स्पेस, 3 डायमेंशन की बात करें. ओके, तो उसने हमें इलेक्ट्रॉन की प्रोबेबिलिटी बताई इंस्टेड ऑफ गिविंग द एग्जैक्ट रीजन. ओके, ही गेव अस वन इक्वेशन, एंड बाय सॉल्विंग दैट इक्वेशन इज Schrödinger wave equation, and by solving that equation, okay, then we will get 3 quantum numbers. उससे हमें क्या मिले? 3 quantum number मिले, not fourth one. We have 4 quantum numbers, but with the help of Schrödinger wave equation we get 3 quantum number, and all 3 are very important. Okay, so what's your Schrödinger wave equation? Just Okay, 11th class. Now just see, this one is your Schrodinger wave equation. Okay, now this equation actually in 1927, Erwin Schrödinger described the wave motion of an electron in three-dimensional space. That one is 3D space around the nucleus. Okay, and he gave one equation for this one, for explaining that wave motion of an electron. So he gave one equation. This one is d square, you know, that one is we are talking about differential. Okay, this symbol, that one is, this symbol is psi, that one is psie, this symbol is psi. Okay, now basically this psi symbol represents amplitude of the wave. Although our main application of psi square is there, we have to study psi square mainly. Okay, so this one is upon dx square plus d square psi upon dy square, then d square psi upon dz square, and this one is 8 pi square m upon h square and e minus v, and this one is psi, that is equal to 0. This expression was given by Erwin Schrödinger for explanation of wave motion of an electron in three-dimensional space. Okay, although 11th class, remember one thing, only you have to learn this equation. Okay, because no solution is required, whatever solution was there, no numericals on this basis, कुछ नहीं है सर, इस equation से काम है. And mainly what's the significance कि उसने कहा क्या था, इससे क्या हुआ था, and you know after that there was a development of quantum numbers, वो इसी से आए थे. Okay, now just see where this one is amplitude of the wave, that one is psi, and this x, y, z, generally x, y, z, they are coordinates of the position of electron, because now we are to x, y, z, we are talking about 3D. Why? Because wave will not travel in 2D. wave खाली ऐसे नहीं है कि दो ही डायरेक्शन में चल रही है, wave कैसी डायरेक्शन में जा सकती है, 3-dimensional space में, and just because of these three, जिसने 3D space की बात करी थी, these gives a rise to the what 3 quantum numbers. Now here this one is d square psi upon dx square, that represents what, that is second differential derivatives of psi with respect to x, in this case with respect to y, and in this case with respect to z. So I have written only for one. This one is your Schrödinger wave equation. Okay, with the help of this Schrödinger wave equation, what he said the electron probability of electron, कि what's the probability of electron around nucleus. Exactly position नहीं बताई, उसने सिर्फ probability बताई कि where is the probability of finding electron is maximum, जहाँ पे आपको ज़्यादा सा कुछ है. Suppose उसने एक picture से कुछ ऐसा देखा था, that one is okay, this side you observe one thing, if like this, wherever is the dark portion is present, जो उन्होंने view निकाला है, okay, this shows the probability of electron, and where the dark portion is not there, means खाली है, white portion is there, so where there the probability of finding electron is 0. And accordingly then definition was there, we have that one is orbital and nodes. On that basis I'll explain you that is probability of finding electron. The two definitions we have to study. Now in short, for Schrödinger wave equation, in short we can write this equation like, that is in short, this one is in short, we can write Schrödinger wave equation like, that one is h, इसको टोपी पहना दे, psi and e psi. This one is simple Schrödinger wave equation, but this one is in short form, that one is h. This one is an operator, actually this is known as Hamiltonian, this is a mathematical operator and that is known as Hamiltonian operator, that is psi is equal to e psi. Okay, now this one is in short. Acha, here this V is a this one is, that is potential energy, and this one is total energy, and this V is potential energy. So this one is your Schrödinger wave equation. Okay, 11th class. Now next thing is, what is physical significance of wave function? Means what's the significance of this psi? Okay, that one is known as wave function. So simple this psi, simple and normal psi gives the amplitude of the wave associated with the electron. And what about psi square? This one is important that you have to learn. Okay, this psi square determines the probability of finding electron, means where is the probability of finding electron is maximum. That one is determined by psi square. It shows what? That one is, this one gives us probability amplitude. ये हमें क्या दे रहा है? That one is probability. This one is probability amplitude, and this represents what? Because this one determines the probability density कि कहाँ सबसे ज़्यादा होगी. So this one is, okay, gives us probability. This one is probability density. Okay, so one simple psi is for probability amplitude and this one is for probability density. Where is the probability of finding electron is maximum in that, okay, atom की सबसे ज़्यादा कहाँ होगी. Okay, now we have two more term. One is orbital and one is node. Okay, in case of orbital, simple. Okay, it's a space, or you can say it's a region where the probability of finding electron is maximum. जहाँ सबसे ज़्यादा इलेक्ट्रॉन पाए जा रहे हैं, the probability of finding electron is maximum. That one is known as orbital. Okay, and in case where the probability of finding electron, the region where the probability of finding electron is 0, that one is known as node. Okay, orbital maximum probability, and here in case of node, okay, the probability of finding electron is 0. Okay, hope so both the terms clear to you, and on that basis simply one question is there. That one is node is okay, orbital is clear to you. Now we have orbit, we have already learned, and this one is orbital. So one general question is there, what's the difference between orbit and orbital? Okay, that will study in another video. Okay, thank you.